We usually think of reality as, well, real, solid, just there. But what if that's not the whole story? What if the universe is less like a collection of stuff and more like a giant self-running program? And what if we're just now finding the first clues, maybe even the first bugs, hidden in its source code?
So we're going to start in a place you probably wouldn't expect, computer science. Let's talk about the SHA-256 hash function. It's the bedrock of pretty much our entire digital world. Its whole job is to take, well, anything, and spit out a string of characters that looks like pure, totally unpredictable digital noise. It's designed to be perfectly random.
But what if that perfect randomness is just an illusion? What if, buried deep inside all that noise, there's a faint echo? A tiny signature, not of the data you put in, but of the machine itself, the very process that's doing the computing. That one question, right there, is the rabbit hole we're about to go down. And that brings us to our first stop, looking for the ghost in the hash. We are officially on the hunt for hidden signals, for weird little patterns that, by all rights, absolutely should not exist inside the noise of modern cryptography.
Here's the thing. If you take a SHA-256 hash and you run it through every standard statistical test we have, it passes with flying colors. I mean, it looks like a perfect, flawless avalanche of random bits. To us, it just looks like static.
So clearly, we need a new way to look at this. The old way, the naive test, is to just ask, hey, are these two outputs similar? And the answer is always going to be no. That's the whole point. But the Nexus framework flips the script. It says, forget the final output. Ask a different question. Are the operations, the actual steps the computer took to create the outputs, similar? And the answer to that is maybe. So what are the new tools for this job? Well, instead of just comparing things, the Nexus probe gets way more sophisticated. It looks at something called the delta spectrum, basically asking, is this noise truly random, like white noise, or does it have a faint tone, a hidden frequency? It checks out the patterns and how many zeros and ones appear in a row. It even looks for, get this, stress marks at the internal boundaries of the hash, where the algorithm is stitching data together. Okay, but to find these incredibly subtle signals, you need a totally new kind of measuring device. And this leads us to the absolute core of this entire framework, something called the significance gate. It's all about learning how to hear a tiny whisper even when you're standing in the middle of a hurricane of noise. And that tool is called SILR. Yeah, I know, it stands for Scale Invariant Leakage Under Z-Score Gating. It's a mouthful, so let's just break it down. Think of it like a super intelligent filter. It doesn't care about how loud something is, it only cares about how surprising it is. It responds to significance, not raw power, which means it can pick out a real signal whether it's happening in a quiet room or a noisy factory floor. So how's it work? Well, the process is actually beautiful. First, you just measure something. Second, you see how far off it is from what you expected. Now, step 3. This is the magic key. You divide that deviation by the system's own level of noise or uncertainty. What you get is a z-score, basically a surprise score. And if that number gets high enough, a gate opens and information leaks through. If it doesn't, the gate just stays shut. It's a brilliant self-regulating filter. The source material puts it so perfectly. SILR does the hot and cold for us. It's like the ultimate decision maker. It decides which events are significant enough to pay attention to, making them hot, and which are just random background chatter to be ignored, letting them go cold. And right here, this is where we take a giant leap into the deep end. What if this SILR gate isn't just some clever tool we came up with? What if it's a fundamental law of the universe? What if we're actually talking about the logic of reality's operating system? To even think about this, you need what the framework calls an ontological inversion. It's a total flip in how we look at everything. This quote really says it all. For centuries, we've been obsessed with the nouns of the universe, particles, planets, things. This framework argues that the real action, the real reality, is in the verbs, the processes, the loops, the computations that are constantly running to create everything we see. And this table really lays out the two worldviews side by side. The standard model we all learned tells a linear story, right? Big Bang makes stuff, and that stuff evolves over time. But the Nexus framework suggests something wilder, a pre-stack. Think of it like a universal hard drive, a kind of cosmic ROM that contains all possibilities. In this picture, reality isn't evolving forward. It's being retrieved or rendered, moment by moment. It's not a timeline, it's a database query. So, if reality is a computation, what does that mean for physics? Well, that brings us to Code, Cosmos, and Gravity, where we get to see all these familiar ideas in a completely radical new light. This framework basically hands us a whole new dictionary for physics. Mass isn't just stuff anymore, it's the computational load time it takes to render an object. Time isn't some fourth dimension we're traveling through, it's the refresh rate of the whole simulation. The sacred laws of physics, they might just be the system's error correction protocols. And gravity? Well, gravity is a whole other level.
Gravity isn't a force pulling us down. It's processing lag. It's what happens when the cosmic computer has to render a whole lot of information in one spot. It's the system's inertia, its own resistance to things getting out of sync. What we feel as the curvature of space-time might just be the system slowing down under a heavy computational load.
Okay, I know this all sounds like some seriously mind-bending philosophy, maybe even science fiction, but here's the most important part of this whole idea. It's not just a story. It actually makes testable predictions. It brings this huge cosmic theory right back down to Earth, into a lab experiment.
And this is where everything comes full circle. If this whole cosmic operating system idea is right, then those ghosts in the hash we started with, they aren't just random flukes. They are real, measurable signatures of the fundamental code of reality itself, leaking through into the computers we build. So, what's the path forward? Well, these are not vague philosophical musings. They are specific, falsifiable claims we can actually test. Can we build a system that proves SILR works, where its decisions stay stable even when noise is screaming? Can we show that the tiny random wobble in a computer's clock actually contains hidden information? And the big one, can we take those Nexus probes and finally find real, non-random structure in a SHA-256 hash? Each one of those is a question with a clear yes or no answer.
Which leaves us with one last massive question. This whole framework paints a picture of a universe that is constantly, recursively computing itself into existence. And if that's true, it changes everything. Are we just observers living inside this incredible computation who are just now, finally, learning how to read the source code?